Welcome to July 20th LeetCode Challenge. Beautiful array. For some fixed n, an array nums is beautiful if its permutation of the integers 1, 2, all the way to n such that for each I less than j, there is no k with I less than k less than j such that the nums at index k is 2 to the times 2 is equal to nums at index I plus nums at index j. Given n, return any beautiful array nums, guaranteed that there is one. So this is quite an odd one. So let's see, how do we go about thinking about this? So we wanted to know whether we want to first notice that a condition is equivalent to saying that, for example, if we have an array that has no arithmetic sequence, then we want to use we want to find something. We want to find a beautiful array such that this condition exists. So what does that mean? So one way is to basically one approach we can want to think of when we think about this is divide and conquer. So the reason why is because the condition is linear. So every time we move down the array, this has to be fulfilled, right? So all the way from basically permutations of n plus n1, 1, 2, all the way to n. So the condition is linear, moving all the way through. And so you want to do a divide and conquer. So we're gonna have a kind of an and we're looking. It's like gonna be a linear type of thing, and we're looking for two conditions. So it's written here, but I'm just gonna write it out. It makes it look a lot nicer. So we have 2 times the array of k will be equal to the array of I plus the array of j, right? That's one condition. We also want to know that I is less than j less than k. No, wait, it's the other way around, j and k. Where I is from the left and j is from the right. So these are the two conditions you want to be met. So we see here that we can guess that the left-hand side of this equation, that has to be even, right? So you want to choose I such that I is going to be on the left side, it's going to be all odd elements on the side, and then the right side here is going to be j, it's going to be all even elements, right? So for example, if say you have a number in the middle, say 5, and then you have you will have 4 and 6, right? And to the left of 5 and 7. So let's see, 4 and 6, the left of 5 and 7, to 7 to the right of 6. So be to the left of 5, and then 7 to the right of 6, right there. So we see in general that odd numbers move towards one direction, being the left, the right, I mean, and then even numbers move towards the other direction, right, being on the left. So that's generally how it kind of looks there. Another way of doing this is by brute force. We just basically want to see all the answers, odd elements on one side, and all the even elements on the other side. But it's another way of looking at it. So to solve this, we're going to use a divide and conquer type technique, and we're going to basically look at the elements from 1 all the way to n, and find out to see if they're even or odd numbers. From that even or odd number, we're going to solve the elements, and we're going to make sure that they are they add up to equal to the results, right? They want to add up and equals to this answer. So that has to satisfy this. Then we just return that into a list. So let's go about solving that. So the first thing I'm going to do is initialize the output, and that's going to be an array of 1. It doesn't really matter what's inside it as long as, I initialized it. array of 0, doesn't really matter. Next thing I'm going to do is do a while loop. So while the length of the output is less than the integer taken into the parameter passed, which is n, while the length of the output is less than n, what we're going to do is we're going to iterate through it and find the odd and even numbers. So we'll call this odd. And we're going to do some list comprehension here. So we're going to do it such that it fulfills the even and odd function demands right here, the condition. So how do we know if something's odd? Well, we know it's odd because it's 2 times I minus 1. That's how it's odd for I in output. So we'll just automatically generate a list out of that for all the odd numbers. How do we know if something's even? Well, it's going to be 2 star I. So 2 divisible by 2 for I in output. So we pass everything through a list comprehension to find even and odd numbers. And what do we want to know? So we know that we have even and the odd numbers for I and j. Next, we want to know whether it adds together to equal this sum, right? Equals the output, I should say. So we want to do output equals assigned to odd plus even. So we're going to combine those two array lists together. And then this we want to return for each element I. So we're going to return another list, but this time it's going to be a little bit different here. So we're going to return for I in output if I is less than or equal to n. Alright, we're going to return for each element I in output if I is less than n or equal to n, because we want it to be within our integers, the permutation to be within the range of 1 to n. And we already know these conditions are filled. The two conditions here are filled, such as I is less than k, which is less than j. And we also know that the odd and even numbers are equivalent to the output that we're going to return in the list comprehension. Alright, let's run it and see if this works. Oh, a little bit fishy, but submit. Okay, accepted. Awesome. So this is using a more or less a divide and conquer type of approach to it. There's other ways of using memoization and making a sub function to helper function to solve this question, but I just find this to be the most kind of how I would do it intuitively. So I guess intuition wise, looking in retrospect, you combine the even and odd numbers together to cover the consecutive numbers between 1 the length of 2 star the length of k, right? And then we look at the number for even and odd, the output here. So if you pick a number from odd and one from even, then the sum is an odd number. So there's no way it would be 2 star numbers of index k. So what you want to do is pick out both numbers from even and odd such that the results are odd, right? Because you want to limit that. Since there's no other way to make an even number from adding an odd number to an even number. So picking out the numbers that won't give you anything, and that's pretty much it. Time complexity and space complexity. So time complexity is big O of n log n, because we do let's see, actually it's big O of n log n, because we return a list comprehension which is n times, and then the while loop here actually runs this runs actually n times, and then the while loop runs every time we get rid of one of the options that's not available in terms of the even and odd addition. We do it log n times, so it'll be n log n. And space complexity is the same n log n as well. Alright, have a great day.